In exercise set 3.3 part 2, we did till question number 9. Now we have to move on and we have to start from question number 10 in this video. Question number 10 says that we have to find out the limit x approaches to 0 cos hyperbolic x, this is hyperbolic function, minus cos of x divided by x sine of x. If we put 0 in place of x here, limit x approaches to 0, if we put 0 in place of x here, we will get 0 by 0 form, and you know very well from the last or the previous videos that this form is basically the indeterminate form. So we have to use the L'Hopital rule here. And what L'Hopital rule says? The L'Hopital rule says that we have to differentiate the numerator of the function separately and the denominator of the function separately. So using the L'Hopital rule, limit x approaches to 0, the derivative of cos hyperbolic x is always sine hyperbolic x. Normally when we take the derivative of cos of x, that is equals to minus sine of x, but the derivative of cos hyperbolic of x is sine hyperbolic x, and also the derivative of sine hyperbolic x is simply cos hyperbolic x. So taking the derivative of cos hyperbolic x, we wrote sine hyperbolic x, then negative sign, derivative of cos of x is minus sine of x. Now come towards the denominator, we have product of two functions, so we have to use the product rule here. Take the derivative of x and keep sine x as it is. Take the derivative of x, that is 1, and keep sine x as it is. Then use the plus sign, keep x as it is, and take the derivative of sine x, that is cos of x. Now simplify, this minus minus will become your plus. If we put 0 in this fraction, we will again get 0 by 0 form. So we have to again use the L'Hopital rule here. Again using the L'Hopital rule, limit x approaches to 0. I already told you the derivative of sine hyperbolic x is cos hyperbolic x, and the derivative of sine x is cos x. Sine x derivative is cos x, plus now we have product of two functions, so use the product rule and find the derivative. That is 1 into cos of x plus x will remain as it is, and take the derivative of cos x, that is minus sine of x. Now simplify this denominator, we will get cos x plus 1 into cos x is cos x, plus minus minus x sine x. This cos of x plus cos of x will become our 2 cos of x. Now put 0 in place of x, so we got cos hyperbolic 0 plus cos 0 divided by 2 cos 0 minus 0 sine 0. This term will goes to 0 and the rest of term will remain, because we know cos hyperbolic 0 is always 1 and cos of 0 is also 1. So we got 2 over 2, that is equals to 1. Now question number 11 says, limit x approaches to 1, 1 minus x plus ln of x divided by 1 minus square root of 2x minus x square. Put 1 in place of x here, we will get 1 minus 1 plus ln of 1 divided by 1 minus 2 into 1 will give us 2 minus 1 square will give us 1. So we will get 0 plus ln 1 is also 0 divided by 1 minus 2 minus 1 will remain 1. So we got 0 over 1 minus 1, that is 0 by 0 form. So we have to use the L'Hopital rule here. Take the derivative of numerator, 1 will give us 0, x will give us 1, and ln x will give us 1 over x. Derivative of 1 will give us 0. Now take the derivative of this square root function. We know very well it is equals to 2x minus x square raised to power 1 by 2. So power down, power minus 1, and take the derivative of inner function without power. So inner function is 2x minus x square. Its derivative will be 2 minus 2x. Now rearrange the terms and simplify them. It will give us 1 over x, this one, minus 1. Then 1 by 2 minus 1, this will be 2x minus x square raised to power minus 1 by 2. That is basically 1 over square root 2x minus x square. So I wrote it like this is our numerator. It will be multiplied with 1 and we will get this, and this function will go down in its denominator. Now take 2 common from this numerator. We will get 2 into 1 minus x. Take the LCM of the upper fraction. We got 1 minus x over x. Now simply we can write it like 1 minus x over x divided by minus 2 into 1 minus x divided by 2 into square root 2x minus x square. Change this division sign into multiplication and take the reciprocal of this fraction. We will get this step. Now we can cancel this 1 minus x with this 1 minus x, this 2 with this one, and simplify the rest of the terms. So we got minus square root 2x minus x square over x. Now we can put the limit value, that is 1. Replace x as 1 and simplify it. We'll get square root 2 minus 1 over 1, that is square root 1 over 1. So we got minus 1. Question number 12. Question number 12 says, limit x approaches to 0, x cos of x minus ln of 1 plus x over x square. Put the value of limit in this function. We will get 0 by 0 form, that is indeterminate form. Now use the L'Hopital rule. Take the derivative of numerator. So this x cos x is in the product form, so use the product rule to take its derivative. Then minus ln 1 plus x. The derivative of ln 1 plus x will give us 1 over 1 plus x. The derivative of x square will give us 2x. Then limit x approaches to 0, we will get cos x minus x sin x minus 1 over 1 plus x over 2x. Now again, if we put the limit in this function or in this fraction, we will again get a indeterminate form. So again, using the L'Hopital rule, derivative of cos x will minus sin x. Now this, due to this minus sign, I have placed the square brackets. Take the derivative using the product rule, x sin x. Derivative of x is 1, sin x will remain as it is, plus the x will remain as it is, and take the derivative of sin x, that is cos of x. This 1 over 1 plus x, this 1 over 1 plus x is basically equals to 1 plus x raised to power minus 1. So if we take its derivative, power down, power minus 1. So this will be equals to 1 over minus 1 plus x whole square. That is this term. Derivative of 2x will be 2 into 1. Simplify the terms, open the brackets, we will get minus sin x minus x cos x minus plus 1 over 1 plus x whole square divided by 2. Minus sin x will be added and this will give us minus 2 sin x. The rest of the terms will remain as it is. Now put the limits, we get minus 2 sine of 0, that will give us 0. 0 cos of 0 will give us 0 because this 0 is multiplying this 1. 1 over 1 plus 0 whole square. So this will give us this value, 0 minus 0, 1 over 1 square divided by 2. So we got 1 over 2. Question number 13. Question number 13 says, limit x approaches to 0, sine of x minus ln e raised to power x cos of x divided by x sine of x. Put the limit, we will again get the indeterminate form, so use the L'Hopital rule. Derivative of sine x will be cos of x. Derivative of ln of this function will be 1 over that function. Now take the derivative of this inner function. This is in the product form, so use the product rule. Derivative of e raised to power x will be e raised to power x, cos x will remain as it is, plus e raised to power x will remain as it is here now, and take the derivative of cos x, that is minus sine of x. Denominator, x sin x, use the product rule to take its derivative, we will get 1 sin x plus x cos x. Now rearrange the terms, take e raised to power x as common from here. So we got e raised to power x, inner will be left cos x minus sin x. divided by this e raised to power cos x. E raised to power x, e raised to power x will be cancelled. Denominator is sin x plus x cos x. Now we will be left behind with this fraction. Now we can see that this cos x can be divided with these terms separately. We can write it like cos of x divided by cos of x minus sin of x divided by cos of x. Cos of x divided by cos of x will be 1 minus sin of x over cos of x will be tangent x. Now open the brackets, we will get cos of x minus 1 plus tangent x divided by sin x plus cos x. Use the limit, we will get again an indeterminate form. So now we have to again use the L'Hopital rule. Using the L'Hopital rule, just take the derivative of numerator. Cos x will give us minus sin x, minus 1 will give us minus 0. Derivative of tangent x is secant square x. And take the derivative of denominator like we already did it many times in the previous questions. Simplify these terms. Now put the limits. The sine 0 will give us 0. Secant square 0. Secant square 0 is basically 1 over cos of 0 square 0. That is 1 over cos of 0 whole square. That is equals to basically 1 over 1 whole square, so equals to 1. 2 cos of 0 will give us 2 into 1, that is 2. This 0 is making this whole term equals to 0, so we got 1 over 2. Question number 14. Limit x approaches to 0, 1 plus sin x minus cos x plus ln 1 minus x over x tangent square x. This is again an indeterminate form if we use this limit into this function. So use the L'Hopital rule. Derivative of 1 will be 0. Derivative of sin x is cos x. Minus will remain minus. Cos x will give us minus sin x. And ln 1 minus x. Derivative will give us 1 over 1 minus x. And the derivative of this inner function will give us minus 1. Use the product rule for taking the derivative of these two functions. Take the derivative of x, that will give us 1. Keep tangent square of x as it is, plus keep x as it is and take the derivative of tangent square of x. So power down, power minus 1 will give us 2 tangent x, and take the derivative without power. So the derivative without power, derivative of tangent x will give us secant square of x. So we will be left behind cos of x minus plus sin of x. This minus I have written here, and 1 minus x. This is basically raised to power 1. So if it goes up, it will be minus 1. 1 into tangent square of x will be tangent square of x plus 2x tangent x secant square of x. Now we can write in place of secant square x as 1 plus tangent square of x. This is another identity that we have used here. In place of secant square x, I have written 1 plus tangent square of x. Open this bracket, we will get 2x tangent x plus 2x tangent cube of x. Put the limit into this fraction, we will again get 0 by 0 form. So again using the L'Hopital rule, limit x approaches to 0, cos x will give us sin x minus sin x will give us cos x. Now this negative sign remained as it is, take this derivative, power down, power minus 1. So minus 1 will be minus 2. Take the derivative without power. This is minus. Take the derivative without power, so we will get 1 minus 0. Now tangent square of x, the derivative will be power down, power minus 1, that is tangent x, and simply without power. So derivative without power tangent x is secant square x. Now use the product rule here for taking its derivative. Take the derivative of 2x first, that will be 2, tangent x will remain as it is. Now keep 2x as it is and take the derivative of tangent x, that is secant square of x. Now same thing happens with this function 2x tangent cube of x. Derivative of 2x is 2, tangent cube x remained as it is. Now 2x remained as it is, take the derivative of tangent cube x. Power down, power minus 1, and without power derivative. Now open all these terms, we will get this fraction. Now we see that we can take common, if we want to simplify this, we can take common from some of the functions. 2 tangent x secant square of x and 2x secant square of x. I can take common secant square of x out of them. And I will be left behind 2 tangent x plus 2x. All other terms I have written as it is. Put the limit into this fraction, we will again get 0 by 0 form. So we again have to use this L'Hopital rule. Using the L'Hopital rule now, limit x approaches to 0, minus cos x plus minus sin x. I have taken the derivative one by one. Like if we see the previous function, derivative of minus sin x is minus cos x. Cos x derivative is minus sin x. Then power down, power minus 1. We will be left with this function and without power derivative. Check the derivative denominator. Now we have two functions in product form. First, I have taken the derivative of secant square x and keep it as it is. So secant square of x will give us 2 secant x and the derivative without power will be secant x tan x. And the second function remained as it is. Now keep secant square of x as it is and take the derivative of this inner function. That will be 2 secant square of x plus 2. Move on to this one. 2 tangent x will give us 2 secant square of x plus 2 tangent cube of x will give us 2 power down power minus 1 means 2 into 3 tangent square of x and without power will be secant square of x. Now move on to this ending function. We can see that here we have 3 functions multiplying with each other. I have taken this as one function and this one as second function. So first we have to take the derivative of first function, keep second function as it is. Now keep first function as it is and take the derivative of second function. So we will be left behind minus cos of x as it is, then minus sin of x, then minus plus minus minus. So minus 2, 1 plus x raised to power minus 3. 2 secant x, secant square of x tangent x. Then this term came as it is, this one as it is. 2 3s are 6 tan square of x, secant square of x. Now take the derivative of 6x tangent square of x. Again use the product rule here. So take the derivative of 6x first, keep tan square of x as it is. 6x will give us 6, tangent square of x remains as it is. Now 6x will remain as it is and take the derivative of tangent square of x. That is 2 tangent x and without power derivative is secant square of x. And then this ending secant square of x came as it is. Now 6x tangent square of x, this one. Take the derivative secant square of x, power down, power minus 1 and without power derivative is secant x tangent x. Now open all the brackets multiplying the terms, we will get this fraction. Now we can see 4 secant square of x tan square of x, 6 tan square of x secant square of x plus 6 tan square of x secant square of x can be written as 16 tangent square of x secant square of x. This term came as it is. We just have to add up the similar terms. Then we got 2 secant square of x and 2 secant square of x as 4 secant square of x. Now put the value x approaches to 0 in the functions. Minus cos of 0 will be minus 1, sin of 0 will be 0, minus 2, 1 plus 0 will be 1. 16, tan square of 0 will be 0, secant square of 0 will be 1, 4 into 0, then secant square of 0 will be 1, tan square of 0 is 0, 2 secant 4 of 0 will be 2 into 1, 4 secant square of 0 will be 4 into 1, plus 12 into 0 into secant square of secant 4 of 0 will be 1. 10 of 0 is 0. 12 into 0. 10 cube of 0 is 0. Secant square of 0 is 1. Now simplify all these terms. This thing will goes to 0, 0, 0 and then 0. We got minus 1, minus 2, that is minus 3. Here we will get 2 plus 4. So minus 3 over 6 will give us minus 1 by 2.